My project for Niyantra contest is index delay modulation. In this is a modulation technique developed by me for transmission of digital data. And the benefit of using this technology is that it reduces the bandwidth requirement to about 50 to 40%, you can say, of the requirement as in case of present day technology is used. So this is the hardware I have been using to implement the transmitter and the receiver module for this particular modulation scheme. So this is the NI SBREO 9642 kit having an Xilinx FPGA XC3S2000, and these are the analog inputs and output ports. So this Xilinx FPGA kit is used to implement the receiver and the receiver module and the transmitter module both. So this is the analog input source which is used as a message signal, which is like given as input to the one of the analog inputs, and this is the demodulated analog output you can see from the analog output channel given to a speaker. So this analog input is fed to the analog input channel, which is then connected to the FPGA, the transmitter module in the FPGA. So where this analog message signal is then first converted to digital form and then like modulated to give the modulated signal according to the algorithm of index delay modulation. So this modulated signal is then passed to the receiver module, which demodulates this modulated signal according to the algorithm as in case of index delay modulation, and then the output of that receiver module is fed to this analog output channel, which is given to the speaker so as to check how, like, what is the output and how better, like, what is the quality of the decoded signal. So now let us have a look at the VIs developed for this. So this is the VI which is containing both the transmitter and the receiver module. So this is the transmitter module starting. So we can see that these, let us first have a look at the memories and the registers used. So these are the memories and the registers used for the implementation of this modulation scheme. So you can see that there are various, like there are two memories in transmitter and two memories in receiver side. So there's a DAC counter, DAC memory to have the all the values in the range of the voltage range, and there's a sample register which like takes the sample of each at a particular frequency of the message signal, and this is the memory like the transmitter output. So now let us have a look at the block diagrams. So this is the receiver, this is the transmitter. So starting from this, there are two parallel executions. These two are sequentially executed, and with each of them there is a parallel execution of these blocks as well. So this is the transmitter module, and then starts the receiver module. This is the received signal from the transmitter, which is then decoded into the receiver. And then again same like we are doing in the transmitter, there are two sequential executions, and with each of them there is a parallel execution. So these are the two modules, the receiver and the transmitter modules. So by using LabVIEW, the parallel execution have been made possible. Like the timing and the parallel execution are very important things for the implementation of this modulation scheme. So now let us have a look at the practical example, like a demo of the thing. So now we can see that this audio source This is the demodulator output. This is just a sound. This is the analog input from this audio source. This is an analog input fed to this analog input channel, 0th channel, and this is the FPGA where the modulation, the demodulation takes place, and the demodulator output is fed into this output channel, which is now fed to the speaker. So you can see there are some noises because of some timing problem. So I'm working on that to remove the noise. Thank you.